Hey everyone, welcome to This Explainer. Today, we are putting on our everyday detective hats to track down something that is literally disappearing right under our noses. I'm talking about missing energy. Every single day, all around us, energy is constantly transforming. But here's the massive mystery. It doesn't all go where we want it to. In fact, a huge chunk of it is pulling off a great escape. So where exactly does it go? Let's dive right in and see if we can solve the case of the great energy heist. To kick off our investigation, we need to look at a pretty shocking statistic. Imagine you've got a motorcycle. The engine's one and only job is to take the chemical energy stuffed inside that fuel and turn it into kinetic energy, right? Movement. Well, check out these numbers. Only about a quarter, just 25% of that chemical energy actually goes toward moving the bike. The rest, a massive 75%, is completely, entirely wasted. To really ground this in reality, think about the last time you filled up your tank. This guy paying for gas is buying a full tank of chemical energy. But since 75% of that energy is going to be wasted, he is basically paying for his motorcycle engine to get super hot and make a loud noise. The fuel is changing into thermal energy and sound energy rather than just getting him from point A to point B. So it's absolutely crucial that we categorize the two paths energy takes whenever a change happens. On one side, we have what we call useful energy. This is the energy that gets transferred into the exact form we actually want, like kinetic energy to move a vehicle. On the flip side, we have wasted energy. This is the energy that just sneaks out into the environment as an unintended byproduct, like the heat and sound radiating off that motorcycle engine. Now, the good news is that modern technology is actively trying to fight back against this waste. Take an older style, incandescent bulb, for example. It only changes about 15% of its electrical energy into actual light, meaning a staggering 85% is just wasted as heat. But then look at an energy-saving bulb. It gives off the exact same brightness, but it changes 50% of its electrical energy into light, which drastically cuts down on that wasted heat. They do the exact same useful job, but they waste vastly different amounts of energy. So this finally answers the question of where that wasted energy actually goes. The scientific term we use is dissipated. When energy is wasted, like that 85% of heat from the older lamp, it dissipates. It just spreads out into the surrounding environment, where there is simply no use for it anymore. It gets less and less concentrated until it is entirely 100% unrecoverable. Think about a classic campfire. You've got a pot of water boiling over the flames. The burning wood is changing chemical energy into thermal energy. And sure, some of that is wonderfully useful. It's heating the water, the rocks, and the pot. But what about the steam? A massive chunk of that thermal energy is just escaping directly into the air. Plus, the fire's throwing off light. All that escaping heat and light represents energy that is dissipating right before our eyes. To really visualize this spreading out effect, scientists use physical models like a ripple tank, which is basically just a shallow tray of water. When you disturb one end of the tray, it creates a wave that moves across the water. But as that wave travels further and further, it gradually dissipates. The energy in the wave spreads out, making the wave smaller and smaller until you can barely even see it. The energy hasn't vanished from existence, it's just spread out so thinly that it's no longer useful. And this brings us to a really hard, inflexible rule of science. It is a total one-way street. Once the heat from your lamp or the sound from your motorcycle engine spreads out into the air, it is permanently lost to you. You simply cannot gather up dissipated thermal energy or sound waves, wrangle them back into one place, and store them to be used again. Once it dissipates, it is gone from our usable toolkit forever. So who was the very first energy detective to actually prove this was happening? Well, let's dive into a little history. Back in the year 1845, a scientist named James Prescott Joule was deeply interested in how things worked, and specifically where energy came from and where it went. He built an incredible machine, specifically designed to track energy as it moved through a system. Let's break down exactly how Joule's brilliant contraption worked step by step. First, he had a heavy weight attached to a string. When he let that weight fall, he was using gravitational potential energy. Second, that string was wrapped around a piece of wood attached to a paddle inside a tank of water. So, as the weight fell, the string pulled, making the paddle rotate. Boom, that's kinetic energy. And third, here is the absolute genius part. The spinning paddle churned the water. Joule discovered that when he did this, the temperature of the water actually went up. He proved the energy had finally transformed into thermal energy. But perhaps the most fascinating part of Joule's story is the aftermath. He had successfully, mathematically, tracked the exact transfer of energy from a falling weight all the way to heating up a tank of water. He proved that doing mechanical work creates thermal energy. But, believe it or not, the scientific community of his day completely rejected his findings. His results totally challenged the accepted ideas of the time. It actually took a while for the world to accept that energy really does behave this way. Fast forwards to today, and we actually have the technology to see Joule's discoveries with our bare eyes. Look at a thermal imaging photo of a moving car. Those bright, glowing colors highlight intense heat. You can vividly see the invisible heat waste that Joule was measuring, just radiating violently away from the engine block, the exhaust, and even the friction of the tires on the road. All of that glowing heat is dissipated energy, spreading out into the atmosphere, entirely unrecoverable. And we can scale this concept way, way up. It's not just our daily gadgets or vehicles doing this. Even giant industrial power stations face the exact same reality. Look at the massive amounts of steam pouring into the sky from a plant. Inside, chemical energy from fuel is turned into thermal energy, which becomes kinetic energy in spinning generators, which finally becomes the electrical energy sent to our homes. But at every single stage of that massive process, thermal energy is escaping. Which brings us to the ultimate takeaway from our investigation today. It turns out there is a golden rule at play here. Every time energy is changed or transferred, there is some thermal energy wasted. This wasted thermal energy is dissipated. Whether you are burning fuel in a scooter, flipping on a light bulb, or running a massive power station, 100% total efficiency is literally impossible. Our universe is constantly in the process of generating and spreading out unrecoverable heat. So I want to leave you with this final kind of mind-blowing thought. Look around the room you are sitting in right now. Look at your phone, the lights above your head, or maybe the computer screen you are watching this explainer on. Every single one of those devices is actively changing and transferring energy right this very second. And based on what we've learned, that means every device around you is currently producing wasted thermal energy. Little by little, they are all slowly heating up your room. Thanks for joining me on this explainer, detectives. Keep your eyes open, and I'll catch you next time.